So now we're going to quicksort the array of 12 elements here, these ones, using quicksort three-way partitioning. I'm going to create a new class called Quick. Quick Java is going to have its own sort method. Let's do a little comment here. Sort's an int array. I'm going to make this an array of ints for now. You can always make it generic a little bit later. So the comment telling people that we'll quicksort this array in increasing order. We'll call our method sort. Its return type is going to be void. It's going to take in an int array. And let's see, let me fill in this method a little bit later. Now we're going to have our method partition method as well. So let me fill in a couple of methods. Now this partitioning method, unlike the previous version of Quicksort, is going to be three-way partitioning, which will deal with equal elements. Okay, a little better than the previous version. We're going to have our test cases inside main. Let me just simply copy this int array that we have saved there. You should come up with your own test cases. For this brief video, I'm just going to stick with this one. And we're going to have quick sort this array, and then we need a little method that will print this array. So let's put this helper method here called let's call it show, that displays the array onto the screen. So we'll take in an int array, and it will just simply go through a little for loop and just print the array. Nothing special here. Should probably speed this up a little bit if I get to edit this video. This is fine. And then print a new line down there. That's fine. Okay, so now we have the show method. We should really be testing it real quick. But we'll get to it in a minute. Let's see what we can do. Now, what else? We need an exchange method. Now, this will come in handy in our sort, and well, actually in our partition method. So let's just, this is a quick one, so let's just get exchange real quick happening. So this exchange method, we'll make it private for this class Quick, because Quick's clients need not use the exchange method. It's a very basic swap method, probably one of the first methods that any programmer writes. Okay, it simply exchanges two elements in an array. In this case, it's an int array called A. Okay, so just two elements, I and J, call them, I guess. Positions I and J, let's say. Maybe it's a little bit clearer this way. So we'll just create a temporary variable, call it temp sometimes. People call it swap, whatever. Save away the first one of these two integers in the array, then assign the other one to the first, and then whatever we had saved away, the other one is going to get it. That's it. That's the typical swap. Now we have our three-way partitioning method, and this is really the homework assignment itself, but I'm going to do it. So we'll make this method private. Now notice that it's going to return an int, an array of ints. This is going to be the pair of integers that this partition element will return. These integers will be this, what you see on the right hand side, this LT, less than and greater than, the bounds of the array. The middle piece, maybe we should call it M or something, but let's see. Okay, so first of all, this is going to be the pivot, A of low. I'm going to have an integer I. That's going to be low plus 1. So remember the demo. So I starts just next to low, and then it goes up, up, up. Okay, until it reaches the high piece. And here we have our ifs. It's going to be an if and if-else statements. So as long as a sub I will be incrementing this I, as long as a sub I is smaller than v, we're going to exchange and increment this I. Exchange it with low, increment low, and increment I. Otherwise, let me copy this and move this away. Otherwise, we'll have two other possibilities. The second one is that the element to which I is pointing, A sub I, is actually greater than V. I'll change that in a second. In that case, the high pointer is being decremented. So let's reverse this inequality to be clear. So if A sub I points to something that's greater than the pivot element, then we exchange I with that high pointer and then decrement that high. And now, of course, we have the third possibility as well. And here, the third possibility is just simply that the pivot is now equal to that element at which I points, in which case we simply incremented I. Now, the thing is, we want to return this pair of elements, the low and high. This is the middle region there, right? Containing the elements which are equal to the pivot. So let's get back to our sort. Now this is the usual idiom again that we're getting back to. Now the sort function, the sort method, will call this private sort method, which takes the array as an argument and also two indices into the array. The left index and the right index, call it low and high again, and it sorts the array, that portion of the array that's in between low and high, right? So now you call, the first call to this private method is going to be with low being 0 and high being the entire length of the array minus 1, as shown on line 5 there. And then inside the private method sort, you first check whether the pointers high and low have crossed, and if they have, you just simply return. You never sort arrays of length 1, because the moment the two pointers high and low meet one another, they're both pointing at the same element in the array. That one element is already sorted, so we'll leave it alone. And now comes the matter of selecting the pivot. This is where we select the pivot. And the way we're going to do it is we're going to create a random index in the array by using a random class, which is in the Java util package. So I'm going to create a new integer here, k. And let's create a static field here. Let's call that guy random. So it's going to be a private static field. Call it just random. And our ID is going to import a random package from the Java util package, random class from Java util. And this integer k is going to be the random element selected from that piece of the array in between low and high. And this is the way you call this method. So check the documentation of next int to make sure that this is clear. This just selects a random index k from the right piece of the array, and you exchange that random element with low. That places the pivot in the leftmost position, in position low of the array. And now create that that pair of integers. So this piece of the array is in between LT and GT pointers that you see in the right-hand side in the instructions there. So you partition now. You make the recursive call on the smaller pieces, on the piece from low up to the LT pointer, which is the left end of the middle array, and another recursive call on the right piece of the array, which starts at the GT pointer that you see in the instructions on the right-hand side until the end of the array, the high piece. That's the recursive call. That's it. Now let's see if this works. Let's run this. Of course, we need to show the array. Before we sort, let's see it, and then after we sort, let's see what the array looks like. And this hopefully works, and it seems to work. Of course, this is no proof that the program is correct or that it works. You should create your own test cases. But